Good evening, everybody. My name is Hussein, and joining me today as part of group number 5 are Manveer, Tamika, and Ish. And welcome to our sprint project number 2. So, before we move on to the presentation, I will first be providing you all with a brief presentation outline of what we will be covering for today. So, first, we will provide an introduction and purpose. We will move on then to our variables, then to our linear regression models, the correlation analysis, and the prediction analysis, which will be explained by Tamika, and then finally our conclusion. And also, we will also be providing some of the coding scripts that were involved in developing a lot of these models, or all of these models, I should say. For today, we will be focusing on the following business and analytical objectives. The business objective is to determine if, based on historical based baseball teams' data, if teams are more successful with high offenses, tight defenses, or a balance of the two in order to help stakeholders obtain new insights and improve on strategic decision making for maximum performance. The analytical objective is to use baseball teams' historical performance data between 1871 and 2010 to help investigate, analyze, and gain insights into what performance variables significantly contribute towards a team's success. In sprint project number 1 that we completed before this one, we did this by performing exploratory data analysis of 8 independent variables and correlation analysis to determine if relationships exist between key offensive and defensive measurements. During this process, we plotted histograms, scatter plots, and heat maps to summarize meaningful statistic properties and distribution. In sprint project number 2, we narrowed down and select new independent variables for 4 periods to perform linear regression models, model validation, and then predictions for games one for Toronto Blue Jays and the New York Yankees for the years 2012 and 2015. So just to lay out some of the variables that we have here, our independent variables that we analyzed were the runs scored, the doubles, the triples, earned runs, and hits. And for our dependent variables, we will be looking at games won. And now I will hand it over to Manveer.
Good evening, everyone. My name is Manveer Brar. I am a data scientist for Group 5. Here I am gonna to explain you my coding part, how I did my coding. First of all, I imported all the required libraries which I need for my coding stuff, and I load my dataset from my computer and ignore all the null values. And you can say I am doing filtration for my dataset, and I am finding a correlation of whole dataset and describe the dataset set. After that, I need to filter for a period 1, which is before 1920. I filter a data for period 1. I got a result and found correlation and describe. After that, I'm going to plot a regression plot between games 1 and run score. As in introduction, you already know we are taken independent variables like run score, doubles, triples, errand runs, and dependent variables as a game win. I plot a graph for that, and after that, I am uh, taking my data for a testing and training set for a period 1. I am taking 80% of data for a training and 20% for a testing. Here I fill the values of my dataset TP filter and the data, and I got a result for a train and test which I need. And after that, I am explaining the simple linear regression in Python. If you are not explaining anything, then you will get a error. So you have to explain everything which are you are put in your coding stuff. Here there is an intercept and slope, and I plot for every variable before 1920 which I taken as independent and dependent. I plot the graphs and find the prediction values for that. After doing that, for a period 1, I am taking all the independent variables together for a period 1 and doing training and test for them, taking a 30% of data for a test and test for a training, and I'm gonna to fit my data. A is independent variables, B is a dependent variables. I'm gonna to fit in that test and do prediction for that and find a mean squared error for it. And I also plotted a heat map for a correlation of period 1. After did all the things for all the 4 periods, here is a part for a prediction. I am taking a data for 2012 here, and I'm gonna to calculate the linear model regression for a hits and doubles. And here is a regression coefficient I calculated for hits and doubles, and here is an intercept. Now for a Toronto Blue Jays, I am taking a regression prediction for a multiple regression for a prediction for the data set. Here I am taking hits in 2012 of Toronto Blue Jays is 1346 and doubles 247. I got these values from an Excel sheet, and here is my result. And here is for a New York Yankees in 2012. Same way we can calculate for a 2015. It is a multiple linear regression formula, but you don't need to put this formula. You can import the libraries and pass your values here, then you will get a result here. And next part is visualization explained by my other group members. Here now I am going to hand over this.
Hello everyone, I'm Tamika, data analyst of the group. Today I'll be going over the prediction section of the presentation. Taking data from period 4, 80% of the data set was used for training and 20% for testing, as mentioned earlier. The R2 value between test and predicted value was 24.5%. This model explains that 24.5% of variation in games 1 is explained by independent variables, hits, and doubles. This means that other variables within the dataset explain the residual value of 75.5% in games 1. We further went on to predict games 1 in 2012 and 2015 for Toronto Blue Jays and New York Yankees. For 2012, the predicted number of games won for Toronto Blue Jays was 79, and the actual games won was 73. This resulted in a root mean square error of 6. On the other hand, the predicted games won for New York Yankees was 83, and the actual games won was 95, resulting in a mean square error of 12. For 2015, the predicted games won for Toronto Blue Jays was 82. The actual games won was 73, resulting in a root mean square error of 9. The predicted value for the New York Yankees was 74. The actual games won was 95. This gave us a root mean square error between the actual and predicted value of 21. In conclusion, the model ran shows some relationship. The independent variables that were selected were mainly offensive ones. Although they have some significance to games 1, the determination between offensive and defensive variables is incomplete as an estimate of games 1. Next step is to rerun the model with a mix of offensive and defensive variables for a more robust predictor.